JPA query. So these are the topics that we are going to cover. Let's talk about JPQL enhancements made in JPA. So support for dynamic queries in addition to named queries. Named queries sometimes called the static queries, and polymorphic queries, and bulk update and delete operations, joins, group by and having, subqueries, and additional SQL functions such as upper, lower, and things like that. We are going to cover each of these in a bit more detail using examples. So I'm moving to the next slide. A continuation of JPA query features. So static queries basically are the queries that you define with annotations in your Java class. So annotations that you can use include a named query for JPQL and named native query annotation for statically defining SQL native query. Dynamic queries are the ones that you can create during runtime, and you can use both JPQL language or native SQL language, and you can use either positional parameters or named parameters. And entity manager is a factory for query objects. So you're going to call the entity manager object and then methods that are provided by entity manager class. Create named query, and create native query. And you can also have query methods for controlling max result, pagination, and flush mode. Again, we are going to cover in the rest of the presentation each of these features. So let's do basic query support, something that you expect from any query language, Java-based query language. So this is how you are going to use where clause. So here, this is the JPQL string. Here we are trying to get all employees whose name is Sang Shin. So you use where and e.name equals Sang Shin. Kind of obvious. Here, the second example, you're using or the operation. This is either name is Sang Shin or salary is greater than 7,000. And this is whose name start with a pattern. And here, in means the name has to be one of these three names. And you can also use not in. Okay, so pretty obvious examples. Range example. So here we are creating query with first result, meaning this is the position of the first result to retrieve, starting from 0. So this is basically starting from a second row, and then max result is the maximum number of results to retrieve. So number of results that you want to retrieve in a single shot. Order by, so I like to have a result ordered by ascending order by name and descending order by salary. Again, pretty obvious examples. Query parameter, you can have either positional parameter or named parameter. So first example is a positional parameter. So here the positional parameters will be specified with question 1, the first one, and question 2. And then you are going to use set parameter, and the first the argument will be position number, and the second argument is the value for that positional parameter. And here, so I'm setting the name positional parameter with Sang Shin, and I'm replacing second positional parameter with a 7,000. So here I'm retrieving all employees whose name happen to be Sang Shin or the salary is greater than 7,000. This is using named parameters. So here the parameters are named. So I chose a very creative name of X and Y. You can name it any way you want. And then you are going to set parameters. So this is the name of the parameter, in this case X, and this is the name parameter Y. Okay. All right. So again, pretty obvious. Group by and having. So this is a case that we are using group by. So display number of people for each salary. Okay. So this is the way that you can use group by. So you can see these are pretty similar to native SQL. JPQL in these examples are very similar to SQL using pretty much the same semantical statement, group by and having. So only difference you see is that basically these are in fact classes rather than table. Okay, group by and having. So in this case, display number of people for each salary among the ones above 5,000. So if you want to have the more conditional group by, then you are going to use having the keyword. All right, so let's do each of these doing the demo and hands-on lab. So if you can download hands-on lab, you can try things with me. Okay, so let's try with where clause. So the code is pretty much the same that we have seen in the presentation. So I'm going to just run the application. And so here we have this employee table, employee ID, name, and salary. Okay, so this is a case that we are using. The name is Sang Shin. We should have only one entry. And here is a case where let me just maximize it. This is a case where either is Sang Shin or salary is 7,000. So we should have two people. And this is the pattern. Yeah, so it is pretty obvious. So let me just move on. The next one is range. Okay, so same employee table, and here we are using range. So this is a case that we are, yeah, it should actually, looks like the statement is not completely correct. So, so let's actually, in this case, looking at the example code. So this is a case that we are, yeah, we are getting all employees, and then, yeah, we are getting I should actually say with max result 2, 3, okay, and this one is first result, max result, range example. Oh, okay, so this is example 1, example 2, and what is the difference? Oh, okay. So, basically it's a little bit of different syntax. That's all. Okay. So same thing with max result. Yeah, just to make sure that this is resulting at 2. So I'm going to just say with max result of 2. Max result of, okay, something like this. Okay. So let's just run it again. Yeah. What happened? Looks like I have a syntax error or what? Okay. Oh, I was changing the wrong thing. Okay, my apology. Yeah, yeah, I thought I was actually changing the comment. Okay. All right. Yeah, my mistake. Yeah, I thought actually I was changing the comment. Anyway, so you got the point. So I'm gonna just move on. And next is order by. So here, let's run the application. Okay, so this is order by, so first by the, okay, so order by name. So the names, the ones that actually can see the names are in ascending order. And then we are using descending order of salary. Okay, all right. The next one is parameters. So here, Let's take a look at the code. This is the same code that we have seen in the slide. So here we are getting all employees whose name is this positional parameter or salaries too. Okay, so this is the case salary 7,000, this is 8,000. So we should have a little bit different result, but it worked as expected. Okay, so same employee table, and here we are getting people whose salary is over 7,000, and this is whose salary is over 8,000. Okay, now let's do group by and having. So let's run this application. Okay. So this is a case group by salary. So you can see the results are based on salary. So for salary 4,000, there are one person. For salary 6,000, you have two people. For salary 10,000, you have two people. And here we are displaying only people. We are actually displaying people only whose salary is over 5,000. So the same thing, and we are constraining this result over among the people whose salary is over 5,000. So we are going to see only just two cases. Okay. Okay. Moving forward. Yeah, so this is relatively straightforward. Okay, named query. Sometimes you call it static query because it doesn't get created during runtime. We actually define it during compile time. So this is an example of named query. So here you are using @named query annotation, and you give a name of the query, and then you define the query string like this. Okay, and you can of course use the parameters. In this case, we are using named parameter, and then you are going to call from entity manager object call you're going to use create named query method, and you provide the name of the named query. So in this case, this one. So I'm using find customer by name query that I define right here, and then I can set parameter, in this case customer name to Smith, and then I call get result list in a chaining fashion. So this is another example. So pretty much the same thing. So we define another named query called the customer find by zip code, and query string is this. Okay, and again, this is the named parameter. And again, we are going to call create named query method, providing the name of named query that we define over there, and we're setting the named parameter with a zip with particular zip code, and then you're ready to move on. Okay. So question from, okay, so Benoit, how can we see the real SQL queries in which JPA translate JPQL query? Okay, so here when you see the persistent XML file, so there is actually a flag that you can set. Okay, so if you see the XML, so if you set this one, okay, if you uncomment this line, then you are going to see detailed logging message, which include SQL, okay? Statement that what the result of translation. Okay, yeah, we covered this one in our previous webinars. Okay, all right, moving forward. Okay, so let's try named query. Again, pretty straightforward. Named query. Here we go. So this is the example that we have seen. So let's actually take a look at the name query first. You define your name query with your entity class. So this is employee class. So here for employee class, I have defined two named queries. One is called high salary man. So I'm getting all employees whose salary is over some value. And then I have defined another named query called employee by name. So here, basically, I'm getting all employees whose name happen to be this. Okay. Now we can use that named query in our main method here. So here we are basically using both. Okay. So we are getting we are using high salary man named query and employee by name query, and we set the parameters, right? This is the positional parameters, and this is the named parameters. Okay, so again, pretty straightforward. So let's try to run this application, and the result should be something that is what is expected. Okay, so again, we have employee table, and these are the people who has salary over 8,000, and this is the employees whose name happen to be Sang Shin, I think. Yeah, so that's named employee by name. Okay, moving forward. Dynamic query. So dynamic query is pretty simple concept. You can create query based on some business logic. So in this case, let's assume that you have some business logic that result in some string that you can then use to construct a query during runtime. So again, you are creating another fragment of your query string. So these two method just simulating result of business logic during runtime, and then you can call create query passing whatever the query string that you have created. Okay. All right. So let's do dynamic query example. So again, this example is very straightforward. I'm just setting the S1, S2, during runtime. Okay, but basically this is resulting some business logic. That's typically how that should result in some the string. So here then we are just using S1 and S2 for creating query, and then rest of the code is again pretty straightforward. So let's do dynamic query, and that result is something that we expect. Okay, all right. Can you do one example from scratch? Okay, so we have done this one in our previous, webinar. So it's very simple. Basically, in our case, these are all Java code. Okay, so basically, you are going to create a new Java code. Of course, you can use JPA in Java code as well as, typically in web application or EJB application. So in this case, you are going to just create the Java application, and then you call XYZ. So yeah, maybe I should actually use uh, the uh, um, the hands-on lab documentation of our. Yeah, why don't I actually move on? Because I think this is something that we covered before. So if you have time, we'll cover this. Okay, so I'll get back to your question and we'll try to create from scratch. Okay, I want to finish things first, and we'll try to create these things later on when we have time from scratch. Okay, moving forward. Native query. Native query is basically SQL query. I mean, if JPQL on criteria API should actually meet most of your need. But just in case there is a case where JPQL and the criteria API do not do not meet your need, then you can always go to native SQL. Okay, so you can use the named native query annotation, or you can just create during runtime like this. Okay, so let's say you create native query. This is SQL. Okay, and then you are going to call create native query, and then give the query string, and then this is a resulting class. Okay, so when you call the get result set, this is going to return list of employees. Okay, so let's do native. SQL native. Okay, here you go. The code is pretty much the same. So this is the native SQL string, and then we call create native query, and this is the string that we just defined right here. And then this is a resulting class, and then you call get result list. Okay, so let's run that application. Okay, so this is expected. Okay, so this is native query. So we are basically all employees whose salary is over 5,000. So we have 3 people. Okay, moving forward. What do we mean by persistence? Again, this is something that we covered in the JPA basics and Hibernate basics. So I recommend you to take a look at the slide as well as recording. Okay. Okay, moving forward. Polymorphic queries. So what is polymorphic query? So all queries are polymorphic by default. Okay. So let me actually talk about it using example, then you will understand it much better. So suppose I have this query statement, JPQL statement, select average salary from employees where salary is over 80,000. What it means is that I like to get the average among all employees whose salary is over 80,000. Now, when I'm saying all employees, I'm not talking about not only employee instances, but subtype instances of employee. So if there is manager or student, or actually manager or president, they are subtypes of employee, right? So when I do this average computation, any instance of employee class as well as president class as well as manager class will be included for the computation. So that's what we mean by polymorphic. So when you're using employee class, this one includes all employees, including subtypes of employees such as manager, president, or administrator, and things like that. So relatively straightforward concept. Okay, so here we are going to try polymorphic with a single table and join table. So last week we didn't cover inheritance relationship where you can represent in a single table or join table. Okay, so I will cover this one hopefully at the end of this presentation. I mean, at the end of this session, meaning this current session, because I don't want to actually change the topic for this webinar. So, but let's actually try to run this application, and I'm going to just show you the result. Okay, so polymorphic. So this is a single table, meaning we are using single table strategy. So when you are seeing employee class, you can see I'm using single table inheritance strategy, meaning the resulting table will be just single table that contains columns representing all the fields of the class hierarchy. So here we have employee, and then we have the manager class. Okay, so manager class you can see extends employee. Okay, and so when we do main class, here what we are doing is we are the get all employees whose salary is greater than average salary. So this is what we do. It's select E from employee and where salary is, and then this is actually a subquery which we are going to cover later on. So we can actually perform query statement. I'm sorry, the select statement first, and then that will be used for another query. Okay, so this is in fact called the subquery. Okay, so so in this case, when we are talking about employee, it includes not only employee instance but also manager instance. Okay, so let's run this application. Single table strategy. The result is pretty, the query, as far as the query result is pretty much the same. So in this case, you can see we are using single table strategy, right? So here, employee ID, D type, discriminator type column, name and salary, and then the manager also has another field called the department. So this department is only for manager class, okay? All right, so now, so we have 5 employee object and then 2 manager object, and manager objects are, of course, a subtype of employee class. So here we are basically getting anybody whose salary is greater than average. So we compute all the average value from this one, collecting all this, the 7 employees and compute the average, and then we display only the people who are the above the average. So you can see one employee is above the average, and then we have a 2 manager rows instances that are greater than average. Okay, all right. Okay, another question from, let's see, what do you mean by entity manager? Again, these are the things that we covered in previous webinars and topics. So, I recommend you to take a look at those things. I cannot really spend time explaining the basic concept at the moment. Okay, moving forward. Then we are going to join. So let's see the join table strategy. So if you go to the employee, the parent class. Now we are using inheritance strategy, now using joined. Okay. So, you can take a look at the, Java documentation, to understand what this strategy is all about. Again, this is something that, the presentation and the exercises are in our previous webinar, but we'll cover this inheritance webinar one more time later on because we did not have enough time to cover that last week. Okay, so the code is pretty much the same, okay, but we just happen to use the two table strategy. So let's run this joined example. So you can see you are going to see there are two tables, okay? So one is a table that contains the common fields, meaning parent class. Then we have the manager table. Oh, okay. So this is something I need to change. Table name is, I have something I have to change. Okay, so now the result is the same, right? Okay, all right. Before I forget, just let me just change that. Utility. I'll change it later. Okay. Okay, moving forward. Okay. Subqueries. Yeah, we just saw an example of subquery. So basically, subqueries are, in some situations, it's desirable for the query to utilize a result of separate query in its calculations. So, this is you perform this query first, and then based on the result, you are going to perform another query. Okay, so in this case, this is called subqueries, and this is pretty useful. Okay, as we have seen in our previous example. So here we'd like to, compute this is exist case. We have actually different case. So in this case, find distinct instances of employees whose salaries are higher than their manager's salary. Okay. All right. So we are going to see few examples. Okay. All right. So subquery examples. Subquery. So this one. Yeah, so get all employees whose salary is greater than the average salary. So we perform this query first to get the average, okay? And this one is for getting a max value, and this is for getting a minimum value. And then we perform the outer query based on this result, okay? So let's run this application. Okay, so I am having a problem. So let's see what problem I have here. Oh, duplicate key. Okay, so that means there is a table that was created before and is not initialized, right? Okay, let me see first of all what database table that we are working on this guy. So I go to persistent XML file and I take a look at the XML and I am using which database? I'm using testDB. Okay, so let's go to testDB and make, okay, so it's connected already and this is a table. Okay, so I'm going to just delete all these tables. Okay, and delete this guy. Okay, then run this subquery again. Okay, now it worked. Yeah, usually I, made an application, so it delete the table first, for example, but it looks like this particular example looks like I didn't delete it, something that I'm going to actually clean up after this presentation. Okay. All right, so here basically we are doing a subquery. So anybody whose the salary is above the average, and this one is anybody whose salary is greater than equal or maximum. So there should be one person, but looks like I said 10,000 both of them. So now this is actually minimum. There should be only one because the minimum value is 4,500. Okay, so now next one is all or any. So let's actually take a look at this code. Okay, so this is a case that we so get all employees whose salary is bigger than the salary of all managers, and get all employees whose salary is bigger than salaries of any manager. Okay, so you can see all or any. Okay, so this is sometimes quite useful. So let's run this application. Run. Okay, so result is as we expected. The next example is exist. So this is the one that we have seen in the presentation. So get all employees whose salary is the same as the salary of any manager. So in this case, we actually use exist keyword. Okay, and also actually manager where M salary is the same as the E salary. Okay, and if exist, then we are going to get the result. So let's try to run this application. Okay, so here, employee 5, 7, and 8, 6. Okay, all right. Okay, moving forward. Joined queries. So JPA basically support all kinds of join queries, inner joins, left outer joins, and fetch joins. Again, for those of you who do not understand the concept of inner join, outer join, things like that, take a look at the MySQL course, and that is MySQL join topic, and it explains all these concepts of inner join, outer join, and things like that. Okay, so in JPA, in order to do, for example, left join fetch, you're basically using left join. If you want to make it outer join, then you basically outer join. Okay. All right. So join is again used, when two classes are in join the relationship. Okay. So one-to-many relationship or many-to-many relationship. Okay. So let's do join fetch first. So here, let's take a look at the entities and their relationship. So we have three entity classes. One is manufacturer. So manufacturer has manufacturer entities, and then it has a one-to-many relationship with a product. Okay. Yeah. So again, we actually cover the this one-to-many, many-to-many relationship and all this annotation last week. Okay. Then product should have the many-to-one relationship with manufacturer. Okay. and it also has a many-to-one relationship with the product code as well. Okay, so if you take a look at the product code, you should have one-to-many relationship with product. One-to-many, and it's a collection of product. Okay. Okay, so let's do join fetch. So the code is, yeah, so here you can actually use these two syntax. One is in and then the collection, or you can use join fetch. Either one is fine. Okay. So you basically display all manufacturers who have products whose the markups are greater than $20. Okay, and this is the same thing. Okay, so this is something that we have seen in the presentation. Okay, but you can use this syntax as well. So as long as you understand this syntax, you should be all set. Okay, so let's run the application. I know actually moving a bit fast because I don't, like to finish in an hour. And for you, in order to actually understand all this, I strongly recommend you for you to download the hands-on lab and play around with the exercise, making changes, creating new entity classes and things like that. Okay, so here my goal is to give you, some exposure of the concept. Okay, all right. So let's see. In this case, we have three tables, right? We have a manufacturer table, then we have a product table, which has a markup, by the way. Okay, so we are trying to figure out, all the products whose markup is 20 in relation with the manufacturer, and product code. Okay, all right. So here the query is select M from manufacturer M. Yeah, so this is the syntax, and the result is the same. Okay. So here we are trying to get all the manufacturers who has a product whose markup is greater than 20. Okay, all right. And now traversal. So traversal what I mean by traversal is that you can use Java notation. So let me see what I'm talking about. We are using the same tables, but here we'd like to display all customers whose discount rate is bigger than 10%. So the difference between JPQL and native SQL is in JPQL, you can use this notation. So here, the discount code is a field of customer, and the rate is again a field of discount code class. Okay, so you can change the reference of, in this case, rate using that notation, and very convenient, right? Okay, so that's basically the traversal I was talking about. So let's just run this guy. Okay, so you can see again, we are seeing customer and discount code, and basically we are trying to get, discount rate is 10. Okay, so we are trying to get customer whose discount code and discount rate, rate of discount code is greater than 10%. Okay. Okay, so next exercise, traversal 2. So here we are using, this is the troubles I was talking about here in this example. So display all products whose manufacturer name is Sun Microsystems. Okay, so we are using again that notation to get the name from the manufacturer and from the product. Okay, so let's run this. Okay, so we have again the all manufacturer product and the product code, and here we are actually displaying all product whose manufacturer happen to be Sun Microsystems. And the last example of traversal is okay, so so this is the case of end production collection P, where P markup is, so you can use a markup of the product. Okay, So this is a case that we are using it with inner join. Okay, so this is a case display all manufacturers who have products whose markups are greater than and 20. Okay, for those of you, I'm sure, who are kind of new to SQL, it's very hard to understand the semantical meaning of this, right? Sometimes, what does this, join things mean? How do I translate from this SQL statement or JPQL statement to this, okay? So, today I don't have time to explain all this, but, again, I recommend you to take a look at MySQL course. And MySQL course, we have quite a bit of extensive the exercises for playing around, suppose if you have this kind of the query requirement, how can I construct the SQL statement, okay? So I recommend you to take a look at that course contents. Okay, so let's see. Okay, I'm not sure I just run this traversal 3 or not. Okay, so again, as expected. So let me move on. Advanced query. So scrolling through the result set. So I think we actually covered about this. You can also actually have a hint. In this case, pessimistic locking. Okay, so we are going to talk about, when we talk about Hibernate, we talk about Hibernate concurrency and transaction. We talk about pessimistic locking and the optimistic locking, right? So we are going to cover JPA, transaction and concurrency, later on, and we'll also cover, pessimistic locking and the optimistic locking, how they can be implemented in JPA. Compound key. Again, we are going to cover compound key in JPA advanced topic later on. So you can actually create a compound key, in this case warehouse PK, okay, and then you can use this compound key as an ID class. Okay, so there are in fact two different ways that you can use a compound key. One scheme is using ID class, and then you provide the compound key class, something like this. Well, the point of this particular slide is, you can use a compound key. Suppose you create a compound key, then you can certainly use compound key object for performing find operation. Okay. So again, we'll talk about compound key in a bit more detail in advanced session later on. So I'm going to move on. Okay, bulk update and bulk delete. So you want to perform bulk update. For example, I want to change salary of anybody whose current salary is less than 6,500. Meaning I want to give a raise to everybody whose salary is less than 6,500 by 1,000 and more to 7,500. Okay, so this is a bulk update. So you are going to create a JPQL statement, update employee, and then you're using set keyword, and then you are setting the salary column with this value, the positional parameter, new salary, okay, for anybody whose salary is less than 6,500, okay. All right, and here I'm setting that the named parameter called the new salary, and then I'm performing execute update. Okay, so it's going to update everybody whose salary is less than 6,500 to 7,500. Bulk delete, same thing. So I want to delete all employees whose salary is over the salary limit. Okay, so if the salary limit is 7,000, I want to fire all those people. Okay. Okay, so let's see the example, bulk update. Bulk update. So let's take a look at the code. Okay, so this is the case that we are raising salary to anybody whose salary happened to be 6,500. Okay, so we are going to display employee table before this bulk update, and then we are going to display employee table after bulk update. Okay, so let's run this application. Okay, so this is a case before bulk update. So we have two people whose salary is less than 7,500, Angela and Annie. And then we are performing this bulk update, and now you can see both of them, their salary have been raised to 7,500. Now, bulk delete. Again, we are going to delete anybody whose salary is above the salary limit. So that's the same code that we have seen in the slide. Okay, so let's run this guy. Okay, so we happen to have two people, Bill and Sang, who have salaries over 7,500, and both Bill Clinton and me are fired. Okay, let's see. Moving forward. Functions and aggregates. Functions, this is something I talked about. Now you can use functions. So, for any, so get customer whose name is lower character is Jumbocom. Okay, so I can use lower, the function. This is, I can find out the length of the name. And this is get customers whose email address has net. So meaning whether this net is inside this email address. Okay. This one is absolute value. So get customers whose absolute discount rate is greater than 10%. And well, this is probably not a good example because discount rate is always positive, right? Okay. Get customers whose credit limit mod is 10,000. It does even support mod. Okay. Aggregate. So as you have seen examples, you can get the average, sum, max, min, and all that stuff. Okay. All right. So let's run function one. Oh, okay. So this is the example. So here we are getting get a customer whose name is lowercase is Jumbom, and get customer length of whose names are greater than 15. Get customers, all customers whose email address has .net. Okay, so let's run this application. Okay, so we have this set of customers, and based on this query, we get different set of customers. Okay, as expected. Function 2 is, again, we are using, in this case, yeah, so here we are using ABS, absolute value, and the mod thing. Okay, so again, let's run this application, and things actually return as expected. Okay. All right, discount code, customers. And the last one is aggregates. Okay, so this is average value, maximum value, things like that. So get average credit limit on all customers. Okay, so we are basically computing average of average credit limit of all customers, average and the summation of credit limit of all customers, max of maximum credit limit of all customers. Okay, and get the max credit limit among the customers whose discount rate is less than 10. Okay, so we are using where conditional clause. Okay, so again, it's relatively straightforward. Okay, so as expected. Okay, so I think I'm done. All right, so let me just